Hello everybody, I hope you're all feeling fine and you're ready to take a look at more of our 2017-2018 Alberta High School Math Contest. We're looking at question 8 in this video. Lan likes red or blue chopsticks, while Dan likes orange or green chopsticks. A drawer in a dark room contains n chopsticks of each color. So n red, n blue, n orange, n green. Okay. Lan goes into the room to get chopsticks for both her and Dan. What is the smallest number of these 4N chopsticks that Lan must pick to be sure that both people will get a matched, i.e. same color, pair that they like? Okay? So Dan wouldn't be satisfied with an orange and a green. He needs 2 orange or he needs 2 green. Okay? So let's think about Lan, making Lan happy. And we want to try and be adversarial. We want to think, what's the worst possible thing that could happen? Because it's in a dark room. We don't know what we're picking. Okay? So Lan would like a pair of either a pair of blue or a pair of green. Okay? We've got chopsticks of each color. Okay? So if Lan pulls out a blue, great, we just need another blue to match. Okay? But maybe Lan doesn't pull out another blue. Okay? Maybe Lan pulls out a red. Okay? So that could certainly happen. Okay? Or maybe it transpires that Lan pulls out another blue. Okay? But we don't know. And that's the issue. Now, I'm just worrying about blues and reds here for a moment. Okay? If, in the worst case scenario, the first 2 picks for Lan are a blue and a red, the next pick, assuming it's a blue or a red, is going to be fine. Either it's a blue or it's a red. So Lan needs 3 of these to be satisfied, to be guaranteed that they're happy. But now the question's a little different because there's also Dan, and Dan needs oranges and greens, but we still have a whole bunch of unpicked reds or blues. Okay? So while trying to go get an orange, it's entirely possible that Lan picks all the remaining blues. Okay? And so that would be n blues picked, and all the remaining reds, and that would be n reds picked, before even a single orange happens. Okay? That would certainly be really bad. 2 n chopsticks picked before Dan is even close to being happy. So it's entirely possible that one person just doesn't get satisfied by 2n of the other color, the colors they don't like, being picked. So 2n chopsticks picked, and then finally you're guaranteed to get either an orange or a green. So you pick an orange. Now it'd be great if we got another orange, but we're not looking for what's great, what would be nice, what would be convenient. We're looking for what would be horrible, what would be the worst possible thing. And that's how you approach these questions. What is the worst possible case scenario? And the worst scenario would be we finally are guaranteed to get an orange, and then we get a green. Okay? But at that point, there's only one more chopstick we need to pick, because all the blues and reds have been taken, and so we're either going to get an orange or a green, guaranteed. Okay? So 2n plus 3 chopsticks need to be picked. Okay? That's the worst case scenario. Worst case is all of Dan's color are not picked, or alternatively, if you don't like Lan, all of Lan's color are not picked. And then you need at least 3 chopsticks to get a pair of the color that you need. Okay? So 2n plus 3 chopsticks is what you need. And so that would be an answer of B. Okay, so we bubble in B. And you can now think about it, now that you've seen how this sort of is played out, now imagine they had another friend, Fan, who likes red, not red, let's say purple and brown, right? How many would worst case scenario you need there? 4n plus 3. Okay? And you can make a nice little sort of generalization from there. All right, but that's question number 8. We're going to move on now to question number 9. Thank you guys so much for watching. Feel free to like or subscribe just to stay informed or show your support. And I'll see you for question 9 next time.